Welcome students. Icse 10th Standard Physics Chapter 3 Machines, Technical Terms, Levers, Pulleys, Gears, etc. So let's start with machines. So what is a machine? Machine is a device by which we can either overcome a large resistive force at some point by applying a small force at a convenient point and in a desired direction, or by which we can obtain a gain in speed. So in general terms, we can see in our general life, we have few simple machines which we come across. Like it is our common experience that it is easier to open a nut by use of a wrench than to open it by hand. It is also difficult to pull a bucket of water directly by a well, but it becomes much easier to pull it with the use of pulley. It is difficult to lift up a load vertically, but it becomes easier to lift up along an inclined plane. We can find many such examples in our daily life where the use of machines such as wrench, pulley, inclined plane, gears, etc. are found, and which makes our job easier. And we have the functions and uses of pulley. So what is the first function? In lifting a heavy load by applying a less effort, and it is used as a force multiplier. The example for this is, a jack is used to lift a car, a bar is used to lift a heavy stone, an inclined plane is used to transfer a load from ground to higher level, pulleys are used to lift a heavy load. All these examples, the effort is much less than the load, so the machine acts as a force multiplier. Second point, in changing the point of application of effort to a convenient point. The example for this is, the rear wheel of a cycle is rotated with the help of a chain by applying the force on the pedal. Thus, the effort is applied on the pedal instead of applying it directly on the rear wheel. In changing the direction of effort to convenient direction. So, example for this third point is, a single fixed pulley is used to lift a bucket full of water from the well. By applying the effort in the downward direction instead of applying it in the upward direction, when the bucket is lifted up directly without the use of pulley. Fourth point, for obtaining a gain in speed, a greater movement of load by a smaller movement of effort. Example for this is, when a pair of scissors is used to cut the cloth, its blade moves longer on cloth while its handle moves a little. The blade of a knife moves longer by a small displacement of its handle. Here the effort is more than the load. Clear? Next, we have some technical terms with respect to machine. What is a load? What is a load? Like few technical terms like load, effort, mechanical advantage, velocity ratio, efficiency. So now we'll try to understand what is a load. The resistive or opposing force to be overcome by a machine is called load. Next is, what is effort? Effort, the force applied on the machine to overcome the load is called effort. So what is mechanical advantage? The ratio of the load to effort is called mechanical advantage of the machine. So what is the unit of mechanical advantage? They can ask you. The unit of mechanical advantage, there is no unit because it is a ratio. Next is velocity ratio. The ratio of the velocity of effort to the velocity of load is called the velocity ratio. That is, velocity ratio is equal to velocity of effort by velocity of load. The velocity ratio is also defined as the ratio of the displacement of effort to the displacement of load. Again, the unit of velocity ratio is not there because it is a ratio. So what is work input? Work done on the machine by the effort is called the work input. That is, work input is equal to work done by the effort. What is work output? The work done by the machine on the load is called the work output. That is, work output is equal to work done on the load. What is efficiency? Efficiency of the machine is the ratio of the use of work done by the machine to the work output into the machine by the effort. So the formula for efficiency is equal to work output by work input. And that will be a ratio. And if you want to convert that into percentage, you can do it into 100. We have a principle of machine. When energy is supplied to a machine by applying the effort, it does some useful work. The point at which the energy is supplied to the machine by applying the effort is called the effort point. and the point where the energy is obtained by overcoming the load is called the load point. So input energy is equal to work done at the effort point into displacement of the point of application of effort. Output energy is equal to work done at the load point into displacement of the application of load. So what is an ideal machine? Ideal machine is that machine where there is no loss of energy in any manner. The output is equal to the work input, and the efficiency of ideal machine is 100%. And most common type of losses which we find in machines is the energy lost in overcoming the force of friction between the moving parts of a machine is the most common type of loss we find it in the machines. So now reasons why there is a loss. We have three reasons. What are they? The moving parts in it are neither weightless nor smooth or frictionless. Hence there is a loss. And second point, the string in it is not perfectly elastic. Third point, its different parts are not perfectly rigid. Now we will try to understand the relationship between the efficiency, mechanical advantage and velocity ratio. The mechanical advantage of a machine is equal to the product of its efficiency and velocity ratio. Note, for an ideal machine free from friction, the efficiency is equal to 1 or 100%, and the mechanical advantage is numerically equal to velocity ratio. In actual practice, the mechanical advantage for all practical machines is always less than its velocity ratio, or the output work is always less than the input work. So the efficiency is less than 1 due to some losses of input energy against the friction. Next is levers. So what is a lever? Lever is a rigid, straight or bent bar which is capable of turning about a fixed axis. Levers are the simplest kind of machines used in our daily life, and we have three kinds of lever. That is class 1 lever, class 2 lever, class 3 lever. For that, what you have to do is you have to keep that in mind, that is flea, F-L-E. So in class, that is F is the force, L is the load, F is the fulcrum, L is the load, E is the effort. So if you keep that in mind, you can. Levers are the simplest kind of machines in our daily life. A lever is a rigid, straight or bent bar which is capable of turning about a fixed axis. The axis about which the lever turns passes through a point of the lever which is called the fulcrum. It is generally marked as capital letter F. This point does not move but remains fixed when the lever is in use. Now we have the mechanical advantage of the lever is equal to the ratio of the length of its effort arm to the length of its load arm. See, here in the previous case with machines, we told mechanical advantage is with respect to effort and load, but here we are talking about effort arm and the load arm. Now we have kinds of lever. Depending upon the relative position of the effort, load and fulcrum, there are three types of levers, that is class 1 lever, class 2 lever and class 3 lever. Class 1 lever. In these types of lever, the fulcrum is in between the effort E and the load L. See, as I told you, you have to keep it in mind. Class 1, F. So F-L-E, flea. Flea, if you keep it in mind, if fulcrum comes in between, so it is class 1 lever. If load comes in between, it is class 2 lever. If effort comes in between, it is class 3 lever. So we'll try to understand some more points about this. So in these types of levers, the fulcrum F is in between the effort and the load. Example is a seesaw, a pair of scissors, crowbar, handle of water pump, claw hammer, a pair of pliers, etc. For class 1 lever, the mechanical advantage and velocity ratio can have any value either greater than 1 or equal to 1 or less than 1. Class 2 levers. In these types of levers, the load is somewhere in between the effort and the fulcrum. As I told you, load comes in between. So if you remember F, L, E, then it is very easy to classify. If fulcrum comes in between, it is class 1. If load comes in between, it is class 2. If it gets come in between, it is class 3. So in class 2 levers, the load is somewhere in between the effort and the fulcrum. The mechanical advantage and the velocity ratio of class 2 levers are always more than 1. You should keep in mind. Next, few examples with respect to class 2 levers. A nut cracker, a bottle opener, a wheelbarrow, a lemon crusher, a pepper cutter, a mango cutter, a bar used to lift a load, a door, raising the weight of the human body, etc. Now we have class 3 levers. So what happens in class 3 levers? Effort comes in between the fulcrum and the load. So the effort is in between the fulcrum and the load. The mechanical advantage and the velocity ratio of class 3 levers are always less than 1. The examples for this class 3 lever are sugar tongs, the forearm used for lifting a load, fire tongs, foot thread, knife, a spade used to lift a coal, fishing rod, etc.